Again, today we're graphing functions. All right. Okay, so the definition of a function, first of all. In math, a function is an expression, a rule, or a law that defines a relationship between one variable, x, and another variable, y. Eyes on me, please. Okay, usually x is going to be the independent variable. So a little cross-curricular connection here, guys. What is the independent variable when we're talking about science? What's the independent variable? Tommy, go ahead. It's the thing that, the thing that the scientist changes. Good. And then the dependent variable is what? Mira?
The variable that changes based on the independent variable.
Yeah, exactly. Good job. So when we graph in science, that's what we're talking about. We're talking x and y. X is the independent variable, and then y is the dependent variable. Okay, so just a little connection for you there. But how many of you remember graphing on a coordinate plane, like in 4th or 5th grade? Raise your hand if you remember doing that. Kind of, just at least a little bit, ever in your entire life? Hearing graph. All right, well, then we're going to review. Okay, we have some terms we need to learn. The first thing that we're going to talk about is the origin. The origin is where x and y intersect, right here. All right, the origin, the coordinates of the origin are 0, 0. So we're going to go ahead and write that down right here. 0, 0, and we're going to label that point boy, because why not? Yep. Now, we are going to find the point on the graph that is 5, 3. X equals 5, y equals 3. Yes, go ahead. Oh, yeah. Thank you. All right, thanks. So when we look at ordered pairs, folks, when we look at ordered pairs, I've asked you to keep your chair on the floor, all 4 legs, and your knees under your desk, please. Thank you. All right, X is always listed first. So the next point that we want to find is 5, 3, okay? So if X is first, we're going to look at that 5, and we're going to count over 5 places on the X axis. 1, 2, 3, 4, 5. And here's 5. The 3 refers to Y. So we want to go ahead and count up 3. 1, 2, 3. And we're going to put a point right there. Do this with me in your packet, guys. And we're going to label this with the ordered pair and the name. It wants us to call it school. I think the boy is going to go to school. How many spaces to the right and up must the boy travel to get to school? Owen? 5 to the right and 3 up. Good job. So let's go ahead and write that as an ordered pair. Has anybody heard the term ordered pair before? Not a whole lot. This is called an ordered pair, what I just wrote. This refers to points on a coordinate plane. We will always write the X coordinate first, and then we will write the Y coordinate. You have to have them in parentheses, and you have to have them separated by a comma. So this is the right way to write an ordered pair. Don't skip any of those parts. All right, now we're just going to practice graphing a couple points. The first one we're going to do is 2.5, 3. So how many spaces over to the right should I go for my x-axis if I'm going to graph this ordered pair? Let me erase this. Ashlyn Grandpré? Yep, I'm going to go 2.5 spaces to the right. Good. So here's 1, 2, and here's 0.5. How many spaces up do I go on this ordered pair? Shafiq? I mean, how many spaces up should I go? I went 2.5 to the right. How many spaces up? So we're working on this one right here. What numbers do you see right there? And 3, good. So remember the X coordinate is always listed first, and that's 2.5 in this case. Then next we list the Y coordinate. What number is the Y coordinate? Okay, so how many spaces up do I go? 1, 2, 3, good job. All right, so we're gonna go 1, 2, 3, and we're gonna place our point right there. And we're gonna label it. We're gonna label it with the ordered pair. 2.5, 3. All right, let's graph the coordinates 5, 4. All right, how many spaces over do I go to the right? Uzziah? Good. How many spaces up do I go, Uzziah? Good. So I go 1, 2, 3, 4. And then we're going to label that, whoops, with our ordered pair, 5, 4. Last one. How many spaces to the right do I go, Ashlyn Mason, for this last one that we're going to graph? Okay. And how many spaces up? You got it. Nice job. And let's go ahead and label that. 3, 2. Make sure you're caught up on this slide, folks. Okay, so we've practiced graphing the ordered pairs just a little bit. Now what we're going to do is we are going to graph a relationship between X and Y. So let's take a look at the next slide that you have in front of you. It says Dylan is 3 years older than Ellen. When Ellen was 1 year old, how old was Dylan? When Ellen is X years old, Dylan is X plus 3 years old. Let's just stop for a second. Ellen is 1, Dylan is how old, folks? Ellen's 2, Dylan is? Ellen is 3, Dylan is? Ellen is X, Dylan is? X plus 3, great job. We can actually graph this. So let's take a look at the next slide that you guys have in front of you. And we're going to plot some ordered pairs. All right. This is pretty hard to see on your, let's see, let me see your graph paper really quick. It only goes up to 5. All right. Let's do a little bit of graphing together. We're going to basically do this. Well, here. I'll run through this and then I'll have you guys graph something else. We'll graph on page 27 of your textbook. All right. So if we look at that, maybe it's easier to see up on my screen than it is to see in your notes. All right. So when Ellen is 1, here's Ellen's age down here. This is X. Dylan's age is Y. When Ellen is 1, how old is Dylan, you guys?
4.
He's 4, right? That point is right here. 1, 4. When Ellen is 2, how old is Dylan?
5.
He's 5. When Ellen is 5, how old is Dylan?
8.
Okay, so we would write that here. What do you notice about all of these points? Tommy, hands up, please. What do you notice about these points, you guys? Piper? Yeah. It's 3 years ahead. What? And when I look at these points, they follow a linear pattern, don't they? I can join all of these points with a line. And I could actually use that line to solve the problem. I could say when Ellen, like I could take a look at over here when Ellen is 8, let's trace this up to the line. Dylan would be 11. Ashlyn, go ahead. Oh, I sure did. Thank you for letting me know that. I should have written 2, 5 there. Good job. Okay. All right, so the graph represents the statement that Dylan is 3 years older than Ellen. You guys can tell, just like what we were doing in my class this morning in science, and Mr. Hughes' class, I'm sure you guys did this the other day. You can look at the graph and gather information. Go spit that out in the trash really quickly from the graph. Yeah, you. Thank you. All right, I want you guys to open up your textbooks to page 27, please. Okay, so you guys can see in front of you what we just graphed here with Ellen and Dylan's ages. That's on page 26. All right, before I have you start graphing on your own, what I'd like you to do is find the value of x find the value of x equals, I'm sorry, let me start over. Find the value of x plus 3 when x equals 9. Okay, so look at your graph for this. If you have a ruler or a piece of paper, just use the graph to find it. We're going to find the value of x plus 3 when x equals 9. So x equals 9, that's right here. You're going to trace up, not really with your pencil because it's a textbook, but you're going to see where that x-axis meets the line. And it's much easier to see in your textbook, you guys. And find the value of y over on the side there. What's the value of y when x equals 9? I don't see all of the textbooks open. We all should have our textbook open to page 26 and 27 right now. Mira? Yeah. We are going to have some graphs that are a little bit more complicated. This one's super easy, right? But we might have some that are more complicated. And so you can use that line to solve for y. So x plus 3 equals y. So this is always going to be our y coordinate there. Okay, find the value of x when x plus 3 equals 8. Now, if x plus 3 equals 8, stop please. Where can I find that? X plus 3 equals y. So if x plus 3 equals y and x plus 3 equals 8, is it fair to say that y equals 8, you guys? Yeah. Our function equals y, x plus 3 equals y, and here it's telling us that x plus 3 equals 8. So this is our y value. So if we want to find the value of x when y equals 8, we're going to go over here. And we're going to find where y equals 8, and we're going to trace it over and figure out where it intersects the line. What does x equal when y equals 8? Uzziah? No? Oh yeah, you just look at the graph. You don't even have to do math for this. It equals 5. Just trace it down. Okay. What is the value of x when x plus 3 equals 10? Look at your graph and take a look where 10 is on the y-axis. Where does that intersect the line? What is x if x plus 3 equals 10? Shafiq? No? Yes, I'm sorry. I was looking at the 10 and my brain was processing 2 different things at one time. You're right. Yeah, x would equal 7. Good job. Okay. Now, you guys are going to take a look at the next graph, okay? And what I would like you to do is, I want you to use your graph paper today. Let's see where we can do that. I'm going to have you guys go ahead and you've got 1 through 5 on both the x and y coordinates on your graph paper, right? Just 1 through 5. Okay. So we're gonna graph the following. Let me just skip through this really quick. Okay. Not that one, this one. Okay, here we go. So what I want you guys to do is you are gonna graph some ordered pairs. All right, first we're gonna solve. You can use the graph in your textbook to solve the functions, and then we're gonna graph for the ordered pairs. All right, so here's your function, y equals 2x. All right, so if 2x equals 6, remember this is our function, y equals 6. What I want you to write is the ordered pair for each of these. So what is x when y equals 6? What is x when y equals 10? What is x when y equals 7? And what is x when y equals 0? Go ahead and do that now. All right, so ignore the boxes at the bottom of the page. Let's just look at the chart, okay? You have 2x equals 6, 2x equals 10, 2x equals 7, and 2x equals 0. So in your textbook, what you can do is you can look for the y's and then trace over from the y to see where it intersects with the line. This line has been graphed for you. If 2x equals 6, 6 is my y, because remember 2x is y. That it tells us that right here. We're going to go ahead and trace over, not with our pencils, just with your finger until we hit the line. And then we're going to go down and we're going to see what the x is right there. Okay, what is x when 2x equals 6? Morgan? Yeah, it's 3. So our ordered pair looks like that, 3, 6. And then in your chart below, under the x, you can write 3, where y equals 6. I don't have the chart on my PowerPoint, I don't think. I don't. Sorry about that, you guys. All right, but I do want you to practice writing the ordered pair. So do that next to A, B, C, and D. Where 2x equals 10. So here's 10. Y equals 10. Trace that over. What does x equal when y equals 10? Morgan, x would equal 5. Good. What does x equal when 2x equals 7? Olive, 3.5. Great job. Did you solve that in your brain or did you use the graph? Okay, good job. How about when 2x equals 0? Yeah, when y equals 0, so y is right here. I heard it. Yeah, it's going to equal 0. Good. It's going to equal 0. All right. Are we starting to get there, friends?
Yeah.
Okay. I want us to practice. I want us to practice writing ordered pairs a little bit, and so we'll use the graph paper for that. I'm just going to have you use it to replicate this function, but I don't think we should do that. So let's take your graph paper, and let me grab a piece from myself too. We can do this together.
Would that be this one?
Yeah, it's the big graph paper. Okay. Plugging in over here. So you guys, the point of this lesson is that you can use these graphs of functions to help you solve problems. But you can also graph data to help you represent data succinctly and quickly. All right, here we go. We change the camera. Here we go. Okay. All right, let's just practice graphing a couple ordered pairs. I would like you to graph the ordered pair 1, 2. Yep. What comes first, X or Y? Okay. And where did you put that dot? Did you put it right here? Did you put it right there? Okay, if you put it right there, then you did it correctly. Good job. Let's go ahead and mark that on our graph. go ahead and, on your coordinate plane, go ahead and mark 2.53. Okay, where did you put it? Did you put it here?
No.
Good. Did you put it here?
No.
Yes.
What? No.
Well, let's check. Let's check.
Yes.
Here's X and here's Y. We go over 2.5 and up 3. It should be right here. Now let's go ahead and write the ordered pair above it. Okay. Let's do, somebody throw it out. I feel like I've thought a lot for today and I need you guys to do some thinking. Kylie, this. 3, 4. Let's do 3, 4. All right. X is 3, Y is 4. Did you put it right here?
No, 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 no.
All right, good job. Did you put it right here?
Yes, yes, yes.
Did you write the ordered pair next to it?
Now I have.
All right, somebody else. It can be a fraction. Landon.
3.753.
Ooh, all right. 3.753. I don't know if we can handle that. That's pretty rowdy. How about right here? Is that where we put it, friends?
I think.
We counted over 3.75. So here's 3.5. Oh, you know what? Mine is a little bit off. It shouldn't be quite that far over. Yeah, that's like 3 and. Yeah. So here's 3.5, here's 3.75. I should be right in the middle there. All right. How about another one? Shafiq.
5.5 and 4.
5.54. Okay. That's going to be tough because our graph only goes up to 5. Why don't you change your X coordinate to one that's lower than 5? Yeah, just give me a different X coordinate. 3, okay. We've already got one there. We'll just redo it. 3, 4. That's where that guy is. All right, Carter. Okay, 2.8 and 4.2. Here we go, 2.8, here's 2.5, here's 2.75, so I guess right about here. 4.2
Wait,
should be right about there. Ish.
that's weird. I don't know how.
Yeah, it's kind of in the center. All right, open up your workbooks, please, to workbook exercise 8.
I don't know how I felt. That one.